Here we are on the last page of this fake limit test thing that I gave a while ago to like years ago, and you are hopefully following along here. And again, our testing class is going to look something like this. Number 9 is the very last page. Number 9 says prove f of x equals cotangent of x is continuous or discontinuous at x equals 0. Well, let's pretend you had no prior knowledge of cotangent of x. Although you should have some knowledge of cotangent of x. Actually, you should be able to answer this question immediately. Is this continuous or discontinuous at 0? You should know this. But in case you don't, I don't mean to chastise you through internet video. Cotangent is equal to cosine x over sine x. Okay? And the first thing in our continuity definition is, does it exist there? Well, f of 0 is equal to cosine of 0, which is 1, over sine of 0, which is 0, which is undefined. There's an asymptote there. Since f of 0 is not defined, it's not continuous. That's what you're going to write. Since f of 0 is undefined, write in cursive here, look at that, beautiful. F of x is discontinuous at, I'm not going to write it all out, is discontinuous at 0. Great, I started it, I quit. Okay. Number 10, find a and b so f of x is continuous. Okay. Well, a plus bx is just a line, x is a line, b minus ax is also a line. So all three of these individually are continuous. The only thing we've got to worry about is where this thing breaks. So at negative 2, I've got to make sure the left side piece, which is a plus bx, equals the right side piece, which is really just this point here at x equals negative 2. So technically, this is a stupid trick on my part. It equals x when x is negative 2. Well, if x is negative 2, then x equals negative 2. Yeah, very, very shocking. So when we plug in x equals negative 2 into this guy, because that's where it's headed, even though it doesn't get there, it jumps, we need to make sure it's headed to where this thing is, where it lands, negative 2. So we need negative 2 to equal a plus bx when x is negative 2. That's our first part. So we have negative 2 must equal a minus 2b. And we also need the right side piece, b minus ax, to match up with that negative 2. So we need the left side piece to meet the middle part, and then we need the middle part to meet the last part here. So b minus ax has to equal negative 2 as well when x is negative 2. And what that gives us is a system of equations. So b plus 2a equals negative 2. Well, you can solve a system of equations fairly simple, I imagine. Let's go ahead and solve this one right here for a. Turns out that a is equal to, well, let's draw an arrow here. A is equal to, what, 2b minus 2? So I'm going to take this guy and plug it in for a down here, which means b plus 2 times 2b minus 2 is equal to negative 2. Just because a is 2b minus 2, a became 2b minus 2. Now we got to solve it. I'm going to do it up here. So we're going to take all this chunks and move it up to here. So b plus 2 times 2b, well that's 4b plus b is 5b, minus 4 equals negative 2, which is going to let us know that we're going to add 4, which is 2, and divide by 5. b is equal to 2/5. And if b is 2/5, a is 2 times 2/5, which is 4/5, minus 2, which is 10/5. So a is negative 6/5. And if a is this number, negative 6/5, and b is this number, 2/5, then this thing is continuous because the top part will be negative 2, or approach negative 2 as x approaches negative 2, and the left side will approach negative 2 as x approaches negative 2. The right side. Okay. So, nothing crazy there, just pretty much you're setting pieces equal to each other. Oh man, it's going to happen to me again. There we go. Okay. Where are we at here? Number 10? Alright, last one. Determine if IVT can be used to prove f of x equals 1 on the interval. If not, state why. If so, prove it. Remember, IVT really asks that the thing has to be continuous. So the function must be continuous on the given interval. That's not really a problem. Also, we have to show that at one endpoint it's either above or below what we're looking at, and that's 1 here. and on the other side we have to show that it is also above or below. We have to show that it changes sides. Okay, so let's look at cotangent x. Cotangent x is continuous from pi over 3 to 2 pi over 3. It's actually, it's only discontinuous where sine is 0, which is at pi, 0, 2 pi, 3 pi, 4 pi. So since these don't, pi over 3 to 2 pi over 3 doesn't cross pi, cotangent is continuous there. So all we're going to say is, since f of x is, this is for a, is continuous on the interval pi over 3 to 2 pi over 3, and f of pi over 3, which is our first endpoint, f of pi over 3, cotangent of pi over 3 is root 3 over 3. So f of pi over 3 is this, and f of 2 pi over 3 is equal to, oh man, negative root 3 over 3. Okay, well, this fails. IVT cannot be used. It is continuous, so that wasn't the problem. The problem is that the graph looks like this, if you want to think about it. At pi over 3, it equals root 3 over 3, which is like right here. And at 2 pi over 3, it equals negative root 3 over 3, which is down here. So the graph really looks like this dude here. Yeah, it kind of connects those two dots. But root 3 over 3 is not bigger than 1. 1 is up here. So when the interval in question, the interval we're looking at, which is from here to here, it doesn't cross 1. And even if it did cross 1 somehow, we wouldn't be able to use IVT because our endpoints are on the, both below 1. Remember, it has to be continuous, and it has to go from above to below, or from below to above the number in question. So technically, we need to take out this part. Let's get rid of that. We would write since f of x, well, you can probably delete all this crap too. Your answer will look like this. I'm just trying to save some time here. Since f of pi over 3 equals root 3 over 3, and f of 2 pi over 3 equals this number, what we would do, let's cut this out, we're going to say this. Since this happens, and negative root 3 over 3 is less than root 3 over 3, which is true, but they're both less than 1, IVT cannot be used, and that's what we're squeezing here. IVT, intermediate value theorem, does not hold. Okay, that was a tricky one. Let's get all this out of here. So IVT does not hold because it doesn't go through, doesn't cross 1. They're both below 1. All right. Now we got to do x squared plus 5x minus 6 on 0 and 1. So same thing here. I guess we should check first here. It's continuous because the parabola is continuous. You don't have to prove it. You can say it because the parabola is continuous. At 0, this thing equals negative 6. And at 1, it equals 1 plus 5, which is 6 minus 6. It equals 0. So this thing doesn't pass through 1 either. So we're going to have the same exact answer. I shouldn't have just erased that. Can I go back? There we go. Cool. We can erase these things. It's going to be the same exact thing, except these numbers are changing. Instead of f of pi over 3, we're going to have f of 0. F of 0 doesn't equal this thing. Okay, so nothing's changed with the number. Since f of 0 equals negative 6, and f of 2 pi over 3, not 2 pi over 3, f of our other endpoint, 1. So f of 1 equals 0. And we can see negative 6 and 0 are both less than 1, so all we're going to do is fill in these dots here. Cut you out of there. Cut you out of there. Talking to myself. Negative 6 is less than 0, but they're both less than 1. IVT does not hold. There you go. If the interval had been, let's say, 0 to 3, instead of 1. Now when you plug in 3, you get 9 plus 15, which is what, 24, minus 6, which is 18, slow night. Now we can use IVT, and you would write, I'm just going to say it out loud, since f of x is continuous, and f of 0 is negative 6, and f of 3 is, what do we say, 18, IVT holds because, and you would write this, so you'd write all the same stuff here, except you wouldn't write this part down here. You would write IVT holds because, so IVT holds because f of 0 is less than what we're looking at, 1, which is less than f of 1. 1 is trapped between these two endpoints, or not 1, we changed to 3. So f of 3 would be, what did we say it was, 18? So 18, there you go. So 1's trapped in there, and since it's continuous, f of x must go through 1. And that should make sense. If you look at the graph of this thing, x squared plus 5x minus 6, we know it's 0, it's negative 6, that's down here. At 3, it's 18, that's up here. So this is some kind of parabola looking like this, dude. Okay, and you can see when x is 1, right here, there's a point there. It's got to be, because it's continuous. Okay, that's the whole test. I hope this was helpful. You can shoot me an email if you got more questions, or just talk to me in class, I guess. Okay.